going to say, oh, its learning has changed a little bit. I added more stuff to the calendar. So if you go on to the It's Learning calendar, you can see some what we're doing, when we're doing it, kind of a thing. So when you go in there under courses, semester 2 algebra 3, if you go over here to show calendar, now it shows all of mine, but for you it would just show, I don't have the option to go student view, but it'll show you, if you click on it, it'll show you what we're doing, the homework, when that homework is due, okay, all the way through. It'll tell you if there's a formative, sure, it'll tell you if there's a formative assessment or not, etc., all the way through.
This semester, are we doing the handed, automatically get a point or not, or 2 points?
Same, yep.
Because you said something about you might do it again.
Well, I might tweak it a little bit. We're gonna see how this first homework goes. You know, I might tweak it and say instead of getting 1 full point, you might only get a half of a point just for turning in a blank sheet of paper. Yeah. You know. Okay. Right? But yeah, all that homework stuff is still can be redone. Formatives can be redone. All that stuff. Okay. All right. So chapter 3 is all about solving systems of equations. We're going to start out with 2 equations with 2 variables, okay, which you've done, again, since Algebra 1. Okay? Then we're going to increase that up to 3 equations with 3 unknowns, which I think you did in Algebra also. And you might have dipped your toes into those a little bit. Then we're going to maybe even increase it to 4 equations with 4 variables. Okay? And then I'm going to teach you at the end, I'm going to teach you a quicker, faster, easier, less complicated method on how to solve them after we get through the graphing and substitution and elimination and Cramer's rule. And then you're going to say, well, why didn't you do this all? And I'm going to say, well, you could have. So we're going to teach some matrix type stuff then there at the end. Okay? So if I've got 2 lines, so we're going to be graphing 2 lines, or 3 lines, or 4 lines on one graph Cartesian coordinate system. And so if I have that, if I put lines on a plane, on one single solitary plane, if I've got 2 of them, okay, those 2 lines could cross. Okay? Can they cross it more than once? If they're lines? No. Okay? If they're lines, they can't cross more than 1 time. It's 1 or none, right? Okay, which is evident here by these first 2. Okay? So if they cross once, then this intersection point right here would be the solution. Okay? That intersection point then is going to be called the solution. And then we can classify that system, because we love system classification. That system then is classified as consistent and independent. Okay. So that system is classified as consistent and independent because it intersects at one point in space. Okay. If we have no solutions, because our lines are, what do we call those kind of lines? Parallel lines. Okay. If we have parallel lines, we have no solutions, and therefore it is classified as inconsistent. they can intersect once, none, or what's my third option? What's that one? They can overlap, right? We could end up graphing the exact same line, and then that case would become infinite solutions. And that one we classify as consistent but dependent. Because they're the same lines. Okay? So, we're graphing lines. Give me 3 ways to graph a line. Nope. Graphing calculator is not going to help us because we need to be able to produce it on a piece of paper in a formative homework test, etc. So y equals mx plus b form? Okay. So the first way, probably the most popular way, is putting it into the slope-intercept form. Okay? If I put my lines into slope-intercept form, the first thing that I'm going to do is I'm going to get it y equals mx plus b. Then from there, what am I going to do? Which point am I going to plot first? The y-intercept, right? Okay. So then I'm going to plot the point, really it's 0, comma, b, right? But really what we do is we just go up or down b depending on if b is positive or negative from the origin. Okay? All right? And then what do I do? M is the slope, right? So then we use the slope, which is rise over run, to find more points, right? And lastly, what do we do? After we found like 4 or 5 more points, we connect them, right? Yeah, we just connect them, we graph it. Okay. So that's one way. Probably the method that I'm going to show the most is that way, just so you know. Okay? Double C, did you have another way? Or are you just stretching? Okay. Matt? Nope. What's another way? Nope. Those are forms. Okay? What's another way to graph? Okay, so what do we call that when we throw in inputs and we get an output? T-chart, right? Now, the cool thing with making a T-chart and a line is you can pick either X's to put in or you can pick Y's to put in, right? Doesn't matter which one you pick, okay? But then you plug that in and then you get out the other one, right? Okay? So you can flippity-flop there, that's fine, okay? That's a good one. What's the last one? Rarely do we use it. But sometimes it's the easiest. Nope, because we're doing linear stuff. So not quadratic formula. How many points does it take to make a line? Just takes 2, right? Okay. What are the 2 easiest points to find? Intercepts, right? Yep. Yep. So we find the intercepts. Okay. So you find the x-intercept by making y equal to 0. You find the y-intercept by making x equal to 0. You graph those 2 points, connect them, you got your line. Now, the reason that I don't like doing the intercept method is because, let's say you've got, here, I'll give you this example right here. If I've got 3x plus y equals 4, right? If I want to find the x-intercept, I would set y equal to 0. So I'd get 3x equals 4, so x equals 4/3. How am I going to graph 4/3? Well, it's 1 and 1/3, right? Or it's 1.3 repeating, but how do I graph that 0.3 repeating? What if I'm off by just a little bit? You know what I mean? Okay. Whereas I could always make this be y equals negative 3x plus 4. Okay. And I could go down 4 from the origin, put a dot. From that dot, go down 3, right 1. Down 3, right 1. Or up 3, left 1. Up 3, left 1. Whatever. Whatever. Okay? With me? So the intercept method works, but you might get crazy looking fractions. And you might be divided by a 1/3 or a 1/6 or, Blue is my favorite. Okay? So, let's do this. Graph these 2 equations on the same graph, and then let's find the solution, and then let's classify them. Woo! Yeah, buddy. All right, so first, on both of these, I've got to solve for y. So I'm going to subtract 3x from both sides. Then I'm going to divide by negative 4 in all spots. Giving me y equals 3/4 x minus 2. Okay. So from there, I'm going to go down 2 from the origin, and I'm going to put a dot. Then using my slope, I'm going to go up 3 and to the right 4. Up 3, to the right 4. Up 3, to the right 4. Or I could go down 3 and to the left 4. How else do you, lines are defined as what? Straight. So what do you think, buddy? What's up, Matt? Well, when you divide a negative 3 by a negative 4, what happens to it? With me? Okay. It happens. That's why luckily when you ask questions, most of the time I have an answer. Keyword is most of the time. Exactly. And then when you draw it nice and straight, right, Rip? Yeah. Mm-hmm. Okay. Draw it nice and straight. Boom. There you go. Now, kicker here, key. I'll show you up here. Okay. Now, when I do these, I draw my lines all the way across the graph. Okay. Don't do this. Think about why that's not good. If it intersects down here somewhere, right? Okay? If it intersects down there somewhere, you don't have a line there. But if we draw it all the way across the graph, then we're covered. Okay? So draw it all the way across the graph and then some. Okay? Then we go on to the next one. 4y equals negative 3x plus 16. Y equals negative 3/4 x plus 4. 4, so there. Negative 3, 1, 2, and 3, 1, 2, 3, and 4. 1, 2, and 1, 2, and 3, 1, 2, 3, and 4. 1, 2, 3, 1, 2, and 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, and 4. Okay. So we have a, whoa, I don't want that, I want that going. We have a solution. It's at that point right there. Whoa. At that point right there. And that's the point 4, 1. Now, I can always check my solution by plugging it back into my two original equations and hopefully getting two truthinesses. 3 times 4 is 12, minus 4 times 1 is 12 minus 4, which is 8. So blue checks out. 3 times 4 is 12, 4 times 1 is 4, 12 plus 4 is 16, so green checks out. So my solution here is the point 4, 1, and it's classified as consistent and independent. Yep. Okay. You try that one. So blue is already wide. 1, 2, and 3, and 1. 1, 2, 3, and 1. 2, 3, and 1. 3 and 1. 1, 2, 3, and 1. 1, 2, 3, and 1. Okay. Then let's greenify. So 2y equals negative 6x plus 4. So y then is going to be negative 3x plus 2. So that's going to end up being the same So my solution here, because they're the same, is going to be infinite solutions. And I'm going to classify that then as consistent and dependent. Yes, sir. If it says classify the system. Yep. If it just says solve the system, then you would just need the solution part in. In this case, you would have to put infinite solutions. Okay? But if it says solve and classify, then you need them both. Okay? Try those two. Okay, so there's the answer for that one. And then my solution here would be no solution, because they don't intersect. And then we would classify that as inconsistent. Okay? So, if I'm looking at systems of equations, if my two lines are intersecting, what do I know about the slope? Neither? They're different. Yep. They have different slopes. What about the y-intercepts? Does it matter? Are they the same? Are they different? Does it matter? They can be anything? No. Because what if that intersection point is at the y-intercept, right? Okay. So for the y-intercept, it doesn't matter. Okay. If they're going to be the same line, then what? What about the slopes? Same. What about the y-intercepts? Same. If they're parallel lines and therefore not intersecting, what about the slopes? Slopes are the same, but the y-intercepts are different. Okay. All right. Ready to try one on your own now? Good? Right. Go for it. Try that one. Alright, so negative 5y equals negative 20x minus 15. Y equals 4x plus 3. Ruh-roh, that means that they're the same, right? Mondays. So nice of you to join us.
Yeah, I said I show up.
Atta girl. So those are, my solution then would be infinite. And my classification would be consistent and dependent. Yes? Okay. Try that one. So I get a solution of, what is that, negative 4 comma negative 5? Which makes this system, because it has one single solitary system, or makes it consistent and independent. again, here, if you wanted to, right up in here, if you wanted to leave this as y equals 2/4 x minus 3, because I'm not asking for the equation of the line, that's okay.
So if you're asking for just the equation, you want to simplify it?
Always. Yep, always. Okay?
Do we have questions on homework that ask for just the equation?
No. No. Okay? Last one. Yes, homework is out of the book. I know we haven't gone to the book since November. Gotta go back to the book. Hey, no, I'm so mean. No solution? Which makes the classification inconsistent. Okay? Okay. Homework tonight is out of the book. It is section. It is section 3.1. Okay. 8 graphs. That's why I gave you the 8 sheet there in there, or I gave you pass it out. And then there's one non-graphing type one that you can do out on the side. Tomorrow, yes.
Monday, right?
Tomorrow. Tomorrow. If tomorrow is Monday, then yes, it's due tomorrow.